I think we're good. Yep. Yep. All right. All right. Uh, on track for the next session. If you want to have some sandwiches, this is the last chance. Please take them to your. Otherwise, they go in the bin. We have two local speakers coming up for the next session. One is Liam O'Connor and the other is Robert Coop. That will be immediately followed by the second keynote of the day. So there will be some switching about. So sorry in advance, perhaps, no? So the first speaker is Liam O'Connor. Liam is a GIS developer, and he'll talk on map server in an asset management system. Thanks.
All right. Hello, everyone. My name is Liam O'Connor. I'm a GIS developer and product owner for Compass Informatics. My presentation today is going to be about map server in an asset management system. The asset in question here is the Irish road network, and the system itself is called the pavement management system. I'm just going to start because I'm in Scotland and this is all about Ireland. I'm just going to give some context to the different groups that I'm going to be talking about in this. So first is Compass Informatics. So Compass Informatics was started in Dublin in 1997, being one of the first homegrown companies to utilize GIS in a commercial capacity in Ireland. It continued to grow over the next 2 decades, focusing broadly on transportation, environment, and natural resources, fostering long-standing relationships with Irish state bodies such as the EPA, Environmental Protection Agency, the Irish Water, and the National Centre for Biodiversity, to name but a few. In 2019, Compass was acquired by Traxys PLC. Traxys is a software house started from Leeds University in 2005, initially focused on rail crew optimization. Traxys PLC now has over 15 acquired business units, all operating within transportation, software, and the services arena. And that's within the UK, Ireland, and increasingly within the United States. In 2021, Traxys PLC acquired another Irish company called Icon Geo, and this acquisition was to further complement Compass's growing and expanding Earth observation capabilities. The pavement management system itself is not anything to do with Earth observation, but I just want to give a plug for my colleague Adrian, who gave a talk at the Maynooth chapter of Phosphor-G Local today, entitled Deep Learning and Sentinel-1 for Grazing Detection in Ireland. So check that out on YouTube if you can. So Ireland, in terms of local governance, is broken up into 31 local authorities, and they're represented at a national level by the LGMA, who's the Local Government Management Agency, and they're to help local authorities implement change, enhance performance, that kind of thing. The local authorities themselves are our end users for the system that we build. So that would be civil engineers, road engineers, safety engineers, and then GIS technicians, data officers, that kind of thing. And then we have the Road Management Office. I'm just going to read this directly because it's a bit of a mouthful. The RMO's function is to provide the local authorities in Ireland centralized supports, forms, guidelines, and technology to support improved roads, asset management, outcomes, and consistency in road maintenance and investment. And that's the pavement management system that we develop is one of the main conduits through which they do this. So Compass Informatics, as the software developers, work very closely with the engineers in the Road Management Office to develop the software, add new features. We don't have that much direct connection with users in the local authorities, besides some support items. So that's the stakeholders. And now I just want to kind of answer the question I'm sure everybody's asking is, what is a pavement anyway? So for some people, probably the minority, they might think of the indie rock group Pavement, whose 1995 album Wowie Zowie, you can see the cover of here. But that is definitely going to be the minority. Most people would probably think of this, which is the raised bit up off the side of the road that you walk along. And you'd be correct, that is a pavement. But so is all of this. Well, besides the green bits and the houses and the cars, you know what I mean? And also all of this, which is active travel infrastructure, which has become a major focus of late. And all of our most recent developments have been involved in capturing active travel within our system, because it's a major focus for the ORMO and local authorities. So when we talk about the pavement management system, when we use the word pavement, it's a civil engineering term, which is any human-made surface on national ground that people, vehicles, or animals can cross. So that is, yeah, quite a broader definition than most people might be used to. And then the management system bit, it's pretty self-explanatory, but just as a bit of history, began life as a desktop GIS and map info in the 90s. What they did before that, I'm not too sure, probably spreadsheets. Compass got involved in it in 2010. It's the longest running project at Compass Informatics. And initially it was just creating a web front end. Data was still entered within the map info system. And this did begin to bring some structure to managing roads in Ireland. But it was quite apparent that a centralized system for data management was going to be required. So in 2016, Compass began working with the ORMO to develop this web-based system. And then for the other side of the presentation title, Map Server, for anyone who doesn't know, is an open source platform for publishing spatial data and interactive mapping applications in the web. It was first released in 1997 by its creator, Steve Lime. It's now on Map Server version 8.0. There's an 8.01 actually, but we're on 8.0. It's a founding OSGeo project. It's cross-platform. It's written in C, C++, so it's very fast. And then just kind of one last bit of, excuse me, context. I just want to show kind of where Map Server sits in our overall system architecture. So I'll talk about all of these bits here coming out of the arrows in a bit, but just to note that all of our kind of CRUD operations are in .NET Web Services, and then there's also some Python geospatial web services. While not connected to Map Server, might be of interest to some people here. Yeah, I'll talk about all these bits in a while, but just to know that there's also kind of a suite of mobile apps for data collection that complement the web browser. And now just to kind of move to a slightly more Map Server centric view of things, and just a bit of an index into what I'm going to talk about today. So MapView Builder is our internal system for managing all of our Map Server assets and our workflows. And then I'll talk a bit about CPSI MapView, which is the JavaScript side of things. And that's basically how we get Map Server to talk to the web. And then I'll talk a bit about the kind of secondary applications that our users in the local authorities use the system for. But before any of that, I'll actually just give a demo of the system. So this is Ireland. I'll log in there. All of the portals are broken up by local authority. So if I just turn this on here, we can see this is just the data for Tipperary when they log in. As an aside for anyone who's going to be following Scotland in the rugby this weekend, this is where your new fly half Ben Healy is from, Tipperary. So we've got 88 map layers down here. Most are rendered via web mapping service, WMS. We've got some WFS layers, but I'll come back to those in a bit. It's just kind of to show the general functionality. All of these layers have associated what we call data grids, but you know them as attribute grids. So you can just open those up there, all 88 of those. And then there's various stylings that you can style all of the data under. So here we have different road classifications. And then the real use of this is, I'll just zoom in here. So sitting underneath everything, we have an edge network or topography. So this is where the Python geospatial stuff comes in. So these are just edges with IDs, and then users, what they call schedule them. And that's when they kind of get turned into like your R123s and your L567s or whatever. And then there's a series of modules. So one of the main ones would be projects. So it's mainly for project works. So users will come in and there's these quite complicated forms. And this is kind of the Python geospatial stuff here. So we can just select. Should load, select a bit there. So that's just creating a route, and then those are served as measures along those edges, linear reference back in the database. and then they can put whatever information they want to get against it. So it gets quite granular. You can add in different sections, go down to layers, and they add in information to the different 7 different sub levels in a road, the different materials that go in there. So yeah, quite a granular level of information. And then that will go all the way up to the expenditure for a certain project as well. Then there's speed limits module, bridges module, and then a bunch of surveys. So surface surveys, these are special engineering difficulties, traffic impact numbers, traffic counts, width, and this is pavement surface condition index. Basically, how good or bad is the pavement. So that's just kind of a quick overview of that. I'll come back to the presentation. All right, so we'll just kind of get into the map server side of things a bit more. So first, what is a map file? So a map file are the heart of map server. It's a domain-specific language that kind of looks like XML without the tags. And then I spoke about a map view builder. So the reason we have this is we've got 32 map files, so that's 1 per local authority, plus a national map file, and they're made up of 88 map layers, with up to 352 thematics. So that's a lot of that XML, like without the tags code, which can be kind of annoying to deal with by itself. So MapView Builder is wrapped around a Python library called Mapifile, which is used to parse, modify, and format map server files. How it works is it takes a map file, uses another Python library called Lark Parser, uses a transformer, puts that into a Python dictionary. You can do whatever you want with it. There's a Python dictionary, validates your keys against the map server schema, and then does a pretty printer back out to a map file. And just the kind of anatomy of a map file here. So it starts with a map, ends with an end. Map files contain 1 or many layers. So here's quite a simple layer just for a country's polygon layer. The layer contains a data object. So this is anything that would be compatible with GDAL. Here we just have a database querying in the data. Then we have layers contain classes. Classes contain styles, 1 or many styles, and then classes also contain labels. So how this works within our system. So as I said, we have the map server components over here where we have the map at the top level, which is web information, your output formats, metadata, and contains all your layer objects. Then layers are made up of data, metadata, and classes. So we store the map level data in a single file called pms.map. Then all of our 88 layer files are stored in these separate .layer files that has the layer level information. And then we store all of our classes in YAML files. Map file compile is just a command line application that takes in the template map, which is your pms.map with the list of all the layers, and then also takes in a map file config, which is your YAML file. We use PyYAML to convert the YAML into dictionaries, use Mapifile to convert the layer into dictionaries, iterate through, splice them all together, and output a template map file. So this would be for a single local authority that we would use then for local development. And then we have Mapfile generate, which, so we just have another builds.yaml, which would contain all of our DevOps configs. Again, there's put into Mapifile, iterated through, and then our 32 local authority map files are put out. So if the client comes along and asks for, I can give a quick show here of what the YAML files look like. And then we define all of our classes. Can have different expressions for different layers and different styles for each class, or however you want to do that. So in that way, if the client comes along and they want us to just change the color of a road, we just do it in one of these YAML files, run these processes, and that will output our 32 local authority map files for us. And at this point, I just want to point you to a presentation that my colleague Seth Gervin gave at Phosphor-G in, I'm not going to pronounce that correctly, Princeton, earlier this year on map server features by example. He goes into a lot more detail. Seth is actually the author of Mapifile, and he goes into a lot more detail on Mapifile in there and the excellent Map Server Studio. If anybody's interested in Map Server, I would say check that out. It allows you to design map files in the browser. Right, sorry, down here first. So yeah, I'm just going to talk about the front end side of things a little bit. So all of those forms that you saw earlier are in a JavaScript framework called XJS. It's entirely proprietary, so I won't spend too much time on that. There's also some open layers involved. I'm sure most people are aware of what open layers is. But this is all wrapped up in an application made by a German company called Terrestrius, who have spoken at Phos4G events before. It's called Basics. And what we use is actually inside of that, it's a thing called GeoX, which is a JavaScript library combining open layers and the JavaScript framework XJS, which we use. GeoX is actually an OS Geo community project since 2019, and then Basics kind of builds on top of that. And then CPSI map view is our implementation of Basics, basically. So I'll just go back to the browser quickly and do a little inspect. I can show you those working. So this is cached now. So if we just refresh that, we can see here by just clicking the GeoX objects here, this will create a get map request, sends back to the server, and we'll get our map back for us. Once we open up the grids, and I refresh it, these grids, all of this data is actually filled out by the web feature service data. So we can see here that it's made a get feature request. If we do a filter on one of these, we'll filter for a cycleway, we get 2 requests. So one again is a get feature request to filter out the grid, and the other is a get map request to filter the map in the background. And there's also select by shape, so that would create a B-box filter for you and send that back. And then we have export functionality as well, export to Excel, export to shapefile or to a shape zip, which also issues a get feature request just with an output format sent. So yeah, that's kind of the JavaScript side of things in a nutshell. Yeah, so now I'll just talk a little bit about these kind of secondary uses that our end users use of our mapping services. So one is OGC API. So this was added to Map Server in version 8, so sometimes called WFS3, which essentially works like an API, exactly like an API. So this is our collection of bridges in the system. Our end users haven't really taken this up yet, but we see great use for it in something like Power BI, because at the moment they're going into our system, exporting Excels, loading them into Power BI to update their diagrams. But Power BI, which doesn't take WFS as an endpoint, but it will take an API endpoint, so they could just go into the pavement management system, update their data, and have their diagrams updated automatically. But getting people in local authorities to change what they've been doing for years is incredibly difficult, even if it would really save them so much time. I'll come back here. So obviously it's used in many GIS applications in the local authorities, in ArcGIS, they still use MapInfo, and in QGIS. One of the major uses would be in FME to analyze the data and output reports. MapRoad licensing is another bit of software made by a different company, and that's about when councils have to dig up a bit of road, they need to apply for a certain type of license, and depending on how extreme that digging up of the road is, and they take data from our WFS related to some of the survey data I showed earlier, traffic impact numbers, special engineering difficulties, to figure out what license they need to apply for to dig up the road. And then finally, just one of the last uses we have of it. So as I said, we've got 88 map layers, which means we've got 88 of those grids or attribute tables, and they're all written in a kind of XJS, JSON-like declarative thing. That's very annoying to work with, and it's a lot of code and a lot of really repetitive code. So we use, to get around that, we have a little library called MapView Grids, which uses OWS lib and the Jinja templating library. So OWS lib will allow us to access the WFS. So this is the definition for a single column within one of our grids in that XJS language. And this is I don't know if anyone's familiar with Jinja. This is the Jinja templating language. So we can actually read in the WFS type here, and if it's a Boolean, it'll create this kind of grid with the, rather than true, false, yes, no, and Boolean filter. This is an integer field, it would create an integer column. If it was a time instant type or date field, it would create like a date filter and stuff like that. So that's just a kind of a nifty little way that internally we use the WFS to make our lives easier. So we don't have to deal with the XJS language. And that is it. Thanks. I don't know if there's questions, but I'll find out. I can just kill that completely now. And that. There we go. Hi, sorry.
Are you collecting all the street gazetteers from all 32 authorities and bringing them into the system? Or do they supply them to you to build this? Or
They supply, so the underlying network is Prime 2, which is OSI's, the national kind of data network.
okay.
So that's kind of sitting under everything, and then they need to go and turn those into actual roads, so go through, and they've been doing that over the last 15 years. So now exists as a proper road schedule. Now recently we have started, we've put digitizing into the system because OSI aren't creating active travel routes as fast as the local authorities want them. So we're building in so they can do that, but we still don't want to break from Prime 2 because we get updates all the time. So we're coming up with all sorts of creative ways to allow routing between networks without breaking where we are at the moment.
Have you got any next steps for new developments in terms of your
New developments coming up?
yeah, just branches and things that you can go down?
Yeah, so we've got we work on 6-month build cycles, so it's constantly new features going in. So we're putting in a module for traffic counters. So when you drive along, there's those pneumatic things that you drive over and across the road. So we're going to put those into the system, and we're also doing something for something called LA60, which is about when a collision with a fatality happens. So we're building an app. It's done on paper at the moment. It's quite great actually, but that data will be done to our systems. Things are currently working. Oh, there's a mechanical data it's where a truck will drive along and take 10-meter values of, I don't know what they are, things called scrim and LGV, road engineering kind of things. Yeah, there's constantly
And things that you can link to as well.
possibly, yeah, the local authorities in terms of managing their roads. Well, there is a whole speed module in there. I don't know if we actually have the locations of speed cameras. If the local authorities needed that, we would put it in.
Yeah, I did a bit of work for Highways England before, and they had where you could click on a camera and you had live feeds and things to open to the public. So I don't know if you've got the same in Ireland.
I'm not too sure. I think I've noticed it more over here, driving around these roads, that you'll get updates on speed cameras coming through that we wouldn't really at home. So I don't know if that exists as a right.
More questions?
Thanks, everyone.
Thank you. So the second speaker this session is Robert Koop. He's the co-founder and head of technology at Coordinates. And he'll be talking about CART, practical data versioning for rasters, vectors, tables, and point clouds.
Cool. Do you want to start now or wait for a couple of minutes?
No, you can.
You're all
You
good?
can start now. Yeah.
Cool. So we're going to talk about CAT, and it's been interesting just sitting here listening to different people talk today, Brian and Amy and Mike and Liam, about some of the data challenges they all have, and so hopefully I'll get to some of those. So I'm Rob, I'm from Coordinates. We are a geospatial data management platform. we help organizations host and share and publish and access geospatial data sets. And we've been really working with open data for a long time. And we do that. Traditionally, we've been based in New Zealand and Australia. We've now got a bunch of UK clients in America and Canada and all sorts. So, but I'm not here today to talk about that. I'm here today to talk about versioning. And what I want to talk about is data versioning in particular. And so it's a really common thing for people to have to deal with data. We all deal with data. We bring it in, we do stuff to it, we lose track of where it came from, we do all sorts of things. How many people here consider themselves as some sort of a developer? A few, maybe a third. So besides having to make computers do what they want all day, they're pretty lucky people. Things that we struggle with in geospatial is like switching between tasks and projects, which maybe have the same sorts of data, but are in different states. Software developers can do that using their versioning tools. We struggle to publish data regularly and reliably, and the people who use data, which is us as well, struggle to figure out what's changed and when, and keep up to date and look into history. With open source software, we've seen how powerful accepting contributions can be. And we also see that in things like OpenStreetMap, where everyone working together and rowing in the same direction can produce much, much better outcomes, better software, better data than somebody necessarily dictating how it is. And Liam referred to that a few minutes ago when he was saying that the authoritative data they get doesn't get updated for the active travel stuff as quickly as they want. And so people end up overlaying changes on it, but they don't really have a way to contribute that back. We see clients in our business who really want to be able to peer review work. So somebody makes some changes to a data set and they want their colleagues or other organizations to have a look at it and kind of review it and comment on it and iterate on it until it's right. And then they want to preserve that. And some of the other tools that the software industry has is also things like automating workflows and testing to be able to say, like, is this data still cohesive? What checks do we want to do on it? How can we transform this data into something else that's useful? In the software world, they can do a lot of that, and it's built on top of the versioning systems. And so what we kind of want to see is whether we can do some of that for data as well. We have some opportunities that have also been talked about in different places, particularly open science, is around being able to see where data came from to guarantee that you and I are looking at the same thing and to see what changes were made and when. I kind of touched on data supply chains, but people get data from different places. And so I get some data from Ordnance Survey, they get data from other places, the councils, and it flows through a pipeline. And whether we like it or not, the data that comes to us isn't necessarily the right data. It's not necessarily the right data for us, but it's not necessarily correct either. And it's a real struggle. We work with authoritative mapping agencies and stuff around the world. They want to get feedback and get improvements and get fixes from their users. And it's really hard to kind of accept that and to bring in those changes in an efficient and kind of useful ways. I know of a couple of people who run like geocoding services, and they have huge databases of patches and fixes that they apply on the data they get every month. And they don't really have a method for like getting those back to improve the original data. The other thing is cross ecosystem stuff. And so I'm talking software platforms like QGIS and Esri, but we're also talking industries, right? So we have people working in finance or health or in construction or building, and they use completely different software for completely different things than the people publishing the data thought about. If the GIS department is publishing it, they're generally publishing it for GIS users. But somebody designing a building as an architect or as a geologist, or somebody doing analysis of deprivation, has different purposes and different goals for that data. And what we see now is once it's converted from one format or ecosystem into something else, that link is kind of severed. And so often you don't get the data updates again. So it might be published regularly over here, but because I had to change it from a GIS-centric perspective to maybe a healthcare-centric perspective or statistics, then I've kind of done a bunch of work and I don't get the same update next month because I have to do that work again. We think that our versioning tools for data should be able to handle some of that stuff for us. And the last one is reliably use the latest data. Time and time again, I'm sure we've all experienced this. We'll start a project and go and find some great data and source it. And then 18 months later, we're still working on the 18-month-old data because we haven't gone back and found it. And that's just everyone does that too. And so the organizations are working really hard to publish all this new data all the time. The downstream users aren't getting the benefit of that. So all data is versioned, whether we like it or not, whether we pretend it or not, it is. And so we look at someone who dumps shapefiles on a server every month, and you have May, June, and July, and then they realize they messed up and make a second bit of July, and then August. But if we look at more sophisticated version environment, we can see what changed in the data. We can see who changed the data. If we're working in a team environment or a collaborative environment, we can see when it changed. And if we're really lucky, we can see why it changed and have some idea of what we can do. And so we can truck along on this line of pretending everything is a straight line and versions go from the past to the future. Or we can look at a slightly more realistic scenario. And so what I'm talking about here is having, see the mouse up here? No, maybe not. Here, where is it? Here. So we've got like a main line, which we're going to call history, right? And so these are maybe the releases of a data set. But if we're doing work on something, maybe we're a council and we're approving some changes to our planning rules, and these changes are evolving over time. And so we might develop some changes on a branch of the data. And so that's not changing the history of what's released, but that's making those changes across on the side. And then we might evolve them, we might review them, and we might change them to be linked off newer versions of the original. And then when we're ready, we might merge in all those changes, but we don't want to lose all the history of necessarily what's happened. We might have other projects going on at the same time where we're making different changes in different places. And then as we evolve on, we can see that we've got different changes over time. And then we can tag things with releases and say like, okay, this is our September data, and it's for all time going to be September. And we can see at every point the history that these are all linked together. And the important part is the links, not pretending that this month's data is completely different from last month's data. Because we have these links and we know this history, we can explore what's changed and where changes came from. What's my mouse again? So at Coordinates, we built this open source versioning system called CART. And it's open, it's free, it's ecosystem agnostic. We want it to work just as well for our friends in the Esri world as it does for QGIS users or people working in CAD or other stuff. We wanted to make it easy to install as software, and we include a bunch of batteries to do that. It's designed around practical day-to-day use. It's not a big data product for people who have their own software teams to build their own things. And we decided to build it on top of Git, which is the most common versioning system in the software world. And we did that to leverage the work that other people are already doing. people like Microsoft and Google and other people who have massive teams and huge problems and big software repositories, they're doing a bunch of work to improve that. And we can pick up that and focus our time and our limited energy on the geospatial data aspect. So I'm going to show a really brief demo. This is a little bit technical, but I just kind of want to talk about some of the principles and ideas. And so hopefully it will kind of make sense. Why doesn't this go back to the start? Yeah. Okay, this is brief. Okay, so what I'm doing here is I'm going to import some data into a new and empty repository. And so I found some shapefiles, which I got given, and I'm going to bring them into a cart repository, which I've created. And what cart's going to do for me is take all the data from those shapefiles and suck it all in, and it's going to label it with a message, and it does that nice and quickly, and it creates me a geopackage file. And this geopackage file is what I see working with cart. Now, I'll talk a little bit later about what other alternatives you have, but you can see here is a geopackage file. And we're going to have a look at a little tool that will explore the geopackage file, and I can see that it's got the 3 shapefiles I started with. And then while we're versioning that data, which it's just done, and it's saved a version, it's just a geopackage file. So we can play the video. Yes. So in QGIS, we can find our geopackage, and we can bring it into QGIS, and we can start editing our data, and we can, the changes that we choose to make here or anywhere else will be available to persist as versions. So CART's ecosystem kind of agnostic. It doesn't prefer you to use geopackages over PostGIS databases or file Esri things. So what we're going to do here is we've brought in our data. We've got those 3 layers for this little island off the coast of New Zealand. And what we're going to do, I think, is find a road, and we're going to change a property of a road. And so then we're going to change it from 1 lanes to 2 lanes. I don't quite see up there, but we save our changes, and then we can, CART will keep track of those changes that we've made. And we can see we've made 1 update to the road layer. We can see we've changed the lane count from 1 to 2. We can do this in a programmatic way, so we can build apps on top of this stuff, right? We can get it as GeoJSON, we can do other things, so we can see what's changed and start building more sophisticated things to explore our visions. But right now, I'm just going to save the changes to my road and say that, hey, we've done some dual laning work, and now it's got 2 lanes instead of 1. And we can look at the history of our repository, and what we'll see now is that we imported our base data, which is down the bottom, and then we've done our laning work. So this is a really simple history of visions. We've got some other work to do, and so we're going to do some work on new development, which involves roads and buildings and other stuff. And so we've created a new branch for our work. And so now let's go back into QGIS. And remember, this could be our web application that has a database. It could be all sorts of things. And so we're going to zoom in here to this little point, and we are going to do some edits. We're going to add some buildings. We're going to want a name as well. So we're going to save our changes. And then we're going to add a road as well, connect it up to the highway. Don't hire me to build your roads. We can fill in some other details in here as well, give it a name. And this is just general data editing, right? Like it's whatever we want to do. And then once we've saved that, cool, let's say it's unsealed. We can go and see what we've changed. And cart will pick up that we've added 4 building point features and we've added a new road. We can see those changes again. We can see all the attributes. We can explore geometries. And then we can save those changes. In this case, I'm going to save the buildings and the roads separately. And so we're going to add a message. And remember, this forms part of our history. So we want to be as descriptive as possible, which is not what I've done here. We're going to save our road as well. And then we can explore our history again. And so you can imagine this extrapolated from a demo, right? Of like somebody proposes some changes, they evolve over time, and finally everyone's kind of happy, or they get built or accepted. So we can now see that those form part of our history. My name is attached, that data is attached. And then if we switch back to our main branch, which is what's happening in the world while all this has been going on, we refresh in QGIS and everything's, find the button. Refresh our data, it's gone because we switched to a different working branch. But once we've brought in our development, we call it merge, we've taken that history of like the roads and the buildings we added, maybe the evolution of that, and we've saved it into our main history. And so you can see that all these things kind of fit together on top of each other. That one I will skip. So that was a really kind of quick example, but hopefully you get the idea. So working copies are where we work with and edit our data. And we talked about GeoPackage here, but different people work in different software and ecosystems, different industries, and they all kind of want their own thing. So we support lots of SQL databases. We're working towards Esri file geodatabases and CADs. We don't just support vector data, we support point clouds and rasters and grids. And where possible, we kind of work towards cloud optimized formats. And that makes it easier for people downstream to use it. They don't necessarily have to bring all the data to their computer, but they can still kind of keep track of where it is and where it's been. Having these different working copy formats is really key to what we're doing. Different collaborators on the same data set don't need to be using the same technology. They don't need to be using the same data formats. And we do our best to take away some of the limitations so that you can move data from one person to another kind of cleanly. That means that I can make a GeoPackage change, and then I can give the data to somebody else, and they can update their Postgres database. And we can all work together on the same data and the same history. We have this other idea of spatially filtered clones. And we often find that we're working with national scale data sets, but we're only interested in a specific town or a specific suburb of a city. And so we want to just filter down to our local area of interest. The traditional way we do that is to export a whole bunch of data for Scotland, and then find the little island in the Hebrides that we're building a model for, delete everything else, save it, and we're good. But that means that as the Scotland data gets updated, we've kind of divorced ourselves from it again. And so what we can do with spatially filtered clones is get that smaller part of a data set and work with it, but it's still part of the bigger one. And every time we update from the original one, we pull in the changes that are just relevant to our little island in the Hebrides. Not only can we do that in a ready kind of way, we can also make changes to our data, and it fits into the larger one. And so we're not split off from the larger data set, we're just working with a small bit. And we can do that using polygons and expressions. We can save extents, we can do stuff. And every time we pull in new data, that kind of filter gets applied again. For vectors and tables, we're talking things kind of in the to 100 gig kind of size per data set. We can have different data sets in a repository. Data types follow like a SQL kind of model, if you're familiar with that. So we support numbers and floats and geometries and keys and all sorts of stuff. We support different coordinate systems as well. We're expanding that over time, but the idea is that somebody working in the UK national grid day in, day out can grab some data that's maybe like a global data set in WDS84 and can just kind of treat that as if it was UK national grid for a lot of purposes. And one of the other cool things is we can re-import from a snapshot data set into a new commit. And so all of us who get data sent to us by a supplier every month, maybe from like NatWest Bank, and they send you a file and you load it into your system. CART supports doing things like taking that data, treating it as a whole new thing and figuring out those changes that have happened since the last one you got and the one before and the one before that. And so that even if your supplier or your customer is not using CART, you can be the most organized person in the world and you know exactly what changed and when. We also support conflict resolution when we're merging things. So if two people have edited the same thing, we support helping to kind of work through and resolve that too. I'll touch briefly on point cloud datasets. So this is for the idea of building out point clouds and rasters and stuff is so that you can start bringing together all the data for a project in a repository. And so that's not just tables and geo packages, it's all the other types of data that we're starting to work with. And so the way this kind of works is that your actual files are stored somewhere like S3, and you can bring them in and treat them as like a version part of your CART repository. And again, things like this filtering kind of work as well. So you can say that only these 3 or 4 tiles are kind of relevant to what I'm working on from this huge data set that covers half a country. And so CART helps you with that stuff as well. And similarly with rasters, aerial photography, or other like model data, the same sort of things. This is built on cloud optimized geotiffs. And again, most of the actual file data will live in something like S3, but we help you filter it out, make sure you only have the tiles that are relevant to you and bring them down. We have a QGIS plugin, and you can install it via the QGIS plugin manager. So you can have a play with CART as well from there. And I've got a little video of that. And so if you're a QGIS user, you can find CART in the list, you can install it. It will help you install CART itself if it's not there. And it brings in this new panel. And so what I'm going to do here is, before we were just treating QGIS as editing a geo package. But with our plugin, QGIS begins to understand a repository. And so this is the exact same repository we had before with the exact same data and the exact same history. And so it'll help you quickly look at the history and make changes, and you can do your commits and all the stuff I was showing on the terminal before from inside QGIS. And so we can go in here, we can see my new road, because this is the history of the main branch. And we can see here in little letters, we've got the history of those changes we made. We edited the attribute, we added a new road, and we can look at the changes for a particular commit in the history. And we can do things like comparing the attributes, what names and values did we add, and we can also do geometry comparison. So we can see that we've added this. If we change it to, we can swap around base maps and stuff so you can see a bit clearer. But we can do things like swipes and other edits, so you can see like, what did me or somebody else change in this part of the history? How did this change? And kind of explore that on a geographic level, as well as the straight, last month versus this month. we've got a bunch of stuff on our roadmap. Some of the stuff we're working on now is referencing stuff from existing S3 buckets. So if you've got a massive pile of aerial imagery and it's sitting in S3, we want to be able to build a cart repository over the top of that, where it is, so that people can use cart without having to kind of buy into the ecosystem. And for large-scale kind of national asset inventories and stuff, that's going to be really useful. It's mentioned on file databases for our Esri friends. The blend of local and remote raster and point cloud data. Some stuff you want locally because you want to do processing on it. You want to run it through R and do some statistics. You want to bring it into Unreal. You want to do that sort of stuff. Other things you're quite happy to stream into like a web browser or QGIS. And so we want to support that kind of stuff automatically. We're working on interlinking data sets from projects. And so this features in a different sort of way. Somebody has a cart data set of roads, but I'm bringing in my project, which is looking at Glasgow University. And so I've got roads from here, I've got buildings from over here, I've got pipelines or property boundaries, and I want to bring them all together into a single repository for my project, but maintain a history and the links to where that data came from. We're looking at serving APIs and tiles from repository, and I mentioned on coordinate system support as well, so that we can work a bit more smoothly across different coordinate systems. And that's what I had. Please come and talk to me and ask other questions, or check out cartproject.org and keep an eye on what we're doing. And if we're possibly useful if you think Cart might be a good fit for you or a project you have coming up, please come and chat to me.
We have a couple of minutes until we have to switch to the national stream. So if you have any questions.
Yeah. Where can my repo live? Obviously, locally, where you're demonstrating it. Could I keep it on GitHub?
You can keep it on GitHub if it's not massive.
I don't notice.
Coordinates can help you host it in the short term, and we're also, but it is just a Git remote, so you can also keep it on an SSH server. And I've got a document which I've been promising to release for a while, but I haven't finished it, which is helping people kind of set up their own hosting in their organization. But underneath it is a Git repository, so anyway you can put it. Yes.
Conflict resolution.
Yes.
Obviously, as coders, we're used to just seeing this line of text and this line of text and deciding, ooh, and then probably testing it afterwards as well, maybe. But if you're doing that in a visual, is there in the QGIS plugin? Have you got a way of sort of comparing those ones? Is there an idea to do that in the future? Is that?
I think in the QGIS plugin, I think you can see both sides of the conflict and you can pick one. But obviously, at the end of the day, you've got to figure out why two people have edited this thing, right? And so sometimes it'll be easy. It's like, I changed the name and you changed where it was. But it's not necessarily like, I changed the name because you changed where it was. And so sometimes there's yours wins or mine wins, and other times it's just like, nah, this is a mess, I need to start over. And so we support those different things. But you're right, it needs to kind of become better, and I think that some of the stuff in QGIS and in other platforms we want to try and kind of help people with, to guide them through that process of like, here's the three things that clash, what do you want to do about it? How do you see it? How do you compare it? And then what decision are you going to make?
Selfish application question. If one is, for example, using drone imagery and surface models to monitor particular sites, whether it could be for disaster response or reforestation, you mentioned the support for raster imagery. Like, how far does the tool go in terms of those, like, detection of change in that kind of respect?
So we don't do spatial change detection in terms of like, if you take a photo this month and I take a photo next month, figure out what's different. But what we do is look at kind of a tile or image level, so you can keep track of what's there. And what I kind of mentioned before was looking at some of these automated workflows and testing kind of thing. And so our big kind of vision is that you push in your September data and some tool that knows about what it is and what you've taken photos of can go and do some work and figure out some changes and save those in a repository, and then you can kind of review it and kind of set up those sort of like automated things.
More questions?
Yes.
Got Twitter handle on there. Do you have a Mastodon?
Sorry?
Do you have a Mastodon handle to replace your Twitter one?
Yeah. I don't know, to be honest. I don't think we did in August, which is where this slide came from. But yeah, we should.
All right. Thank you. I think we'll move on to the next slide. Right?
Thank you.
X is X.